Hi, I'm Adam. Welcome back to Godot Game Lab. In this video, we'll implement the long-awaited Relics from Slay the Spire. So here's how this looks like in the demo. We have our Relic bar here at the top, and you can see that we have buttons which are disabled by default, but when you do have more than 5 relics, you can use these arrows to navigate between your relics. Also, if you click on one of those, you'll get a description, a tooltip, what they do. So if I click on the starter relic of mine, it says Endless Healing Potion. At the end of combat, heal 6 HP. We can close this just by clicking anywhere on the screen, clicking the back button, or pressing escape. So we have 4 relics here. This one is similar to what the Ironclad has in Slay the Spire. It heals 6 at the end of the combat. This one is called Explosive Barrel. At the start of each turn, it deals 2 damage to all the enemies. We have a rechargeable mana potion, which at the start of combat gains 1 mana to the player. And we have reinforced armor, which at the end of the turn gives 3 block to the player. So let's see how this looks like in a combat, right? So if we go into a battle, you can see that the barrel flashes and all the bad enemies took 6 damage, right? You can also see that besides that, this mana potion flashed as well. And I do have 4 mana instead of the usual 3. So what I'll do is I'll use a defensive card and maybe kill one of those bats. And if I end my turn here, you'll see that 3 block will be added because of this anvil, right? This reinforced armor. So I have 5 block, and if I end my turn, it goes up to 8, so I can fully block the damage this bat deals. Now I won't play any defensive cards on purpose, so I can lose some HP. And I do. And no matter what I do, this bad enemy will die next turn. Oh wait, no it won't because it has block. Okay, so I end my turn again. Okay, so let the bat damage me one more time. So my HP goes down to 25, and then the bat dies because my explosive barrel killed it during the start of my turn. And you can see that from 25, I went up to 31 at the end of combat with my healing potion, right? So all of those relics work together and besides each other, and I can still play the game just like I could before. Let's see how we can do this. So first of all, let's start with a review how the battle flow works for now. If you remember, it starts with applying the start of turn status effects for the player. Then we execute the player's turn. After pressing the end turn button, we apply the end of turn status effects to the player, discard the hand, and when the hand is discarded, we start applying the start of turn status effects to all the enemies. Then the enemies execute their actions. We apply the end of turn status effects to all of the enemies. And when all enemies are done with all of this, then we loop back to the next turn. So again, we had to review this because this will be the last time, promise, that we have to again extend or disrupt this battle flow when we introduce relics to the whole mix. So how will this change? We have quite a few different relics we can use, but only 2 types of relics are applied to this battle flow. So first, instead of starting the turn with the start of turn status effects, we first apply all the start of turn relics instead. Then, when all the relics did their thing, then we move on to the start of turn statuses for the player turn, and then before applying the end of turn statuses to the player, we execute or activate all the end of turn relics. When we're done with that, we can move on to the end of turn statuses, and the rest will be pretty similar to what it was, because for the enemies we don't change anything. So when the player hand is discarded, we move on to start of turn enemy statuses, execute the enemy actions, do the end of turn statuses for the enemies. And when all the enemies are done, we can loop back to the next turn and start by executing or activating all the start of turn relics. Again, we have other kind of relics as well. For example, we have start of combat relics or end of combat relics. We also have event-based relics. So all of those exist, but they don't really disrupt the flow of the battle per se. We execute them once at the beginning of the battle or at the end of the battle or when whatever event occurs. We don't really need to include them to this flow of events, to this loop, which we execute in every turn. So we really need to keep this in mind when we are ready with the implementation of the relics and we want to hook it up for the battles. But what about the relics themselves? So we introduced a new resource called Relic, which you guessed it, describes a relic. And we have two types of code attached to it. We have the attributes and the behavior. So for the attributes, we have a name, an ID, and a type. And the type is like the type of relic we are talking about. So we have start of turn, start of combat, end of turn, end of combat, and event-based relics. And we also have a character type, which can be all characters or one specific available character in the game, because just like in Slay the Spire, we can have character-specific relics. For example, we have relics which can only be used by the warrior or something like that. We also have a Boolean checkbox called starter relic, because you can get starter relics from the shops, for example, or battles. These are excluded from the calculation or the set of relics which can appear as battle rewards or shop relics later on. And we also have the visuals, namely an icon and a tooltip. For the behavior itself, we'll have three base methods, which will be overwritten by all the specific relic codes, just like with statuses or cards. Here we have three methods. One is called initialize, which will be called once when the player acquires the relic. We have an activate, which will be called whenever the relic wants to do its thing. Let that be start of turn, start of combat, or an event callback or whatever. So whatever it is that the relic wants to do, it has to do it in this activate method. And we'll also have a deactivate method, which will be used when the player, for whatever reason, loses the relic. And this might sound confusing at first because there aren't many ways to lose a relic in Slay the Spire, but in some cases it might be useful, and we'll get back to that when we implement the relics. So how these relics are going to be used and by whom? So we have the relic resource, right? We'll have a UI visual representation and an interactable representation of a relic, and we'll call this RelicUI. And we'll also have a RelicHandler, which is like an HBox container in the top bar, and it handles or contains all the relic UIs we have. But it's also like a logical parent, and it handles all the different interactions you can have with relics. So the main part, or the central part of this whole relic system, the brain of the operation, so to speak, is the RelicHandler. So the RelicHandler itself will be used by a bunch of different systems in the game. So first of all, as I said, the RelicHandler will instantiate relic UIs, and it will be used in a bunch of different contexts. Probably the most important one is the run itself, because it will appear in the top bar, so the run will instantiate a RelicHandler, which is like the central part. But then we have to inject this dependency from the run to all the other different places where we actually have to access the RelicHandler or the relics the player owns. For example, the battle, right? It's super important that we have access to the relics in the battle so we can alter the flow of the battle we just talked about. So to do this, we'll inject the RelicHandler dependency from the run to the battle. And we sort of bubble this change or like propagate this, because to change the flow of events, we don't just have to modify the battle itself, but the PlayerHandler script too. So the run injects the RelicHandler to the battle injects the same RelicHandler to the PlayerHandler. And we also have other different systems which we'll need to use the relics. For example, the shop system, which we do in the next video, because you can buy relics in the shop, right? So you need to be able to add new relics to the RelicHandler, for example. And we also have a bunch of different places we might use the RelicHandler later on. The shop is just a great example that we might need it later in different other systems too. For this video, the most important ones are the run, the battle, and the PlayerHandler, because we definitely need to inject the RelicHandler to those to actually implement the functionality we want to. So without further ado, let's get started. Okay, so I have the project open here, and let's get started with creating the relics system. This will be actually pretty similar to what we did with the statuses, with a few changes here and there. So we'll start off by creating a new custom resource for the relics. So let's expand the custom resources folder in the file system, right click on it, create a new script, and let's call this relic.gd. And one neat little trick that one of you mentioned in the comments is that for the template, we don't have to select object empty. If we want an empty template, we can just uncheck this box and we'll have a blank script, which is a pretty neat trick. Then we don't have to always click on this drop down here. So let's press create and double click to open this up in the editor. So as I said, we'll have behavior and attributes connected to this relic resource, but we'll start off with just the attributes for now, and we'll come back to the script when we actually want to provide the behavior as well. And I'll also explain why. So for now, let's just create the base for this, the attributes. We'll start off by assigning a custom class name to the resource called Relic, and then we'll have two enums, one for the type of the relic, which can be the 5 I mentioned in the architecture overview: start of turn, start of combat, end of turn, end of combat, and event based. These 5, I think, cover almost all the relics you can get in Slay the Spire, and we'll see how they can be used. And we'll also have another enum called character type, which can be all assassin, warrior, and wizard. I was a bit torn about this enum, whether it belongs there or not, because it's probably not the best idea to like enumerate all the available characters in the game. It feels like it belongs somewhere else, but I don't really think we need it anywhere else in the project. So it feels a bit dirty to have this here, as it isn't really a relic related thing, so to say, right? But also we have this all, which is like specific to relics, because some relics can be obtained by all the characters and some are character specific. So I ended up not overthinking it and including this enum here in the relic class. But if it bothers you, you might do it in a different way. So it's just something I think worth mentioning, that I know that this might not be the best here. It's a quick and dirty solution, but at the same time, we don't really use it anywhere else in season 2, like an enum for characters. So I think it can remain here. But if you disagree, you can just do an alternative solution. Right, what about the attributes themselves? So we'll have a bunch of export variables, one for the relic's name, one for its ID, one for the 2 enums, a type and a character type. We also have a Boolean checkbox called starter relic, which is false by default. And we have the 2 visual ones, one texture for the icon, and one BB code multiline string for the tooltip. So for now, that's all we need to get started. So let's save this script with Ctrl S, and let's go back to 2D view and add a bunch of relics to the game. So go to the file system doc, we can collapse this custom resources folder for now and actually create a new one for the relics. So let's right click on the root folder, create a new folder, call this relics. And if we select this new relics folder, we can right click again, create a new resource, search for relic, and we'll create a bunch of relics. In this example code, or in this video, I want to create 5 relics for all the 5 different types we can have to kind of show you how you can use those. So the first one will be called coupons. Let's save this, expand the folder so we have it. Yeah, and while we're here, we can add all of those relics and then we can edit the properties. So right click again, create new resource, create a new relic. And this one will be called explosive barrel. Repeat the same process. Let's call the next one healing potion. Create a new one. Call this one mana potion. Create the last one as well. Call this reinforced armor. Okay, so now that we have the relics, we can edit them one by one. So double click on coupons, change the relic name, coupons, same for the ID, but with the lowercase one. And this will be an event-based relic, because this will apply a 50% discount to everything in the shop when you actually enter a shop. So this will be an event, a signal we can connect to, hence the event-based type. So this is not a starter relic. It can be acquired by all the different characters. And for the tooltip, we can do something like this. With a yellow color, we say the name. And then we can say all items in the shop are discounted by 50%. Perfect. We could set the icon, but we'll change the script just like we do with cards and statuses later. So whenever we do that, you know that the texture for whatever reason will become empty again. So there's really no reason to set it for now. We'll do it for one relic just so we can test the RelicUI, but we don't have to do it with all of them. So let's double click on the explosive barrel next. Okay, so the relic name will be explosive barrel. The ID the same, explosive barrel, but with lowercase letters and an underscore. So this will be a start of turn type relic. it can be acquired by all characters. And for this one, we can set the icon. So let's load something from the art folder. And we have this barrel here. And for the tooltip, we can do something like this. At the start of your turn, deal 2 damage to all enemies. Okay, we can move on to healing potion. So the healing potion's name will be healing potion. No surprises there. ID the same with lowercase and underscore. So this will be an end of combat relic, and it's only available to the warrior instead of all the characters, and it's also a starter relic. So it can only be acquired that way when you start a new run. And the tooltip can be something like this: endless healing potion at the end of combat, heal 6 HP. It's similar to the ironclad starter relic in Slay the Spire. Right. We can set the icons, it doesn't take that much time. And set the healing potion icon for this one. Do the mana potion next. So the relic's name is mana potion. ID the same, but with lowercase. And this will be a start of combat relic. It can be acquired by all the characters. And it's not a starter relic. And the tooltip can be something like this. At the start of combat, gain 1 mana. Awesome. And we have the last one, reinforced armor. And the reinforced armor can be called just armor or whatever you want to. The ID can be armor as well. And this will be an end of turn relic. Can be acquired by the warrior only. Not a starter relic. The tooltip will be something like this. At the end of your turn, gain 3 block. Right. We can set the icon as well if we want to. Again, it's not that much time to like set it again if it disappears. Okay. So we have all the relics here, but with no code yet. Let's save this with Control S. And we can actually start creating the RelicUI representation now that we have all the relics as resources available. But before we actually start the RelicUI, there's something we need to do, which I forgot, but it's super important. So let's go back to the script tab, press Ctrl-Alt-O and search for characterstats.gd. Because for the characters, we have to assign a starter relic, right? So let's press enter. And under gameplay data, where we have this export variable for the max mana, we can introduce a new line, an export variable for the starting relic. So that's all we need to do here. We can save this with Control S. And if we go back to 2D view and search for warrior.tres in the file system and double click this, you can see that now we have an empty starter relic slot. And even though we don't have the code for it yet, we can drag and drop a healing potion here. Okay, so now we have a starter relic assigned to the character. And now we can actually start creating the Relic UI. So for the Relic UI, the root node will be a basic control node. So we can click on user interface, rename this to Relic UI, and let's change the layout. So instead of the full rect anchor preset, we can set it to top left and we can change its size, right? So it will be at least 16 by 16. So we can change the custom minimum size. And under this Relic UI with the plus sign, we can add the children, and this will be a texture rect for the icon. Can double click, rename this to icon, and we can load one texture to see how this would look like. We can use whichever we want to. I just use the anvil icon here. Set it to ignore size and set it to keep aspect centered. And under layout and transform, we can set this to 16 by 16. And we can also change like the minimum size to 16 by 16. Okay, so this looks fine, but we have a problem. Because for this Relic UI, we want to create an additional feature. So from a user experience or a UX perspective, it would be nice to like somehow indicate when a relic is activated, right? So we'll do a flashing animation for that. So if we click on the Relic UI, the root node, click on the plus sign or press Ctrl-A, we can add an animation player node. It's a child, so we can create the animation for this. So what we'll do is we'll scale it up a bit, flash it white, and then scale it back down to indicate that the relic is being used. So the problem is, if we select the icon and I try to scale it up, for example, you can see that it doesn't scale from the center, right? So it looks weird. It's like it's nailed to the top left corner, and when we scale it, it grows from there. That's because we don't have a pivot offset. So if we zoom in, you can see that we have these green indicators for the anchoring, but we also have a small little orange plus sign here at the top left corner. And this is the default pivot offset. So if we set this to 8 by 8, which is the center, right? Because we have a 16 by 16 square. So if we set the pivot offset to 8 by 8, you can barely see, but this little orange cross moved to the center. And now if we scale it, you can see that it scales from the center, which is what we wanted. Awesome. So for the animation to work, it's really important that we change this pivot offset property as well, so it doesn't look weird scaling from the top left corner. Awesome. Okay, so that's all the setup we need. We can actually create the animation next. So if we select the animation player, you have this animation dock at the bottom, and we click on animation and new. We'll call this animation flash, and 1 second is way too long. So let's change this to something like 0.3, for example. And you can zoom in by pressing and holding Control and scrolling with the mouse wheel, or by changing this slider at the bottom. So we'll have 3 keyframes, one at the beginning, one at the end, and one at the middle. So let's select the icon and click on this key icon next to the scale to add a keyframe to this property. And it asks you if you want to create a reset track for this, and we absolutely do. So let's just click create and do the same at the end of the animation. And also I can select the halfway marker because the snap is set to 0.1. But if we change this to 0.05, then I can move in smaller increments. And we can set another keyframe right in the middle. And if we select that keyframe, we can change the scale to whatever we like. I just use 1.2 for both sides. And we can see how this looks like. Okay, doesn't look too good yet, but if we add the white flash to it, it looks a lot nicer, I promise. So we already have a material, a shader material for flashing white, because if you remember, we use the same when taking attack damage in the case of enemies and the player. So just click on the icon again. And if you go under, you have texture, rect, control, and canvas item. So under canvas item and material, we can add the keyframe to the material too. Create the reset track. And again, we'll add 3 keyframes. And for the middle one, we want to change this value. So instead of empty, we can press quick load. And we have this white sprite material here. And now you can see that if I scrub through the timeline, it will change this material, and we have like this 0.15 seconds where it's white. So if I play the animation now, it looks like the relic flashes. Awesome. You can play with this animation. So if you don't like it, you can change up like the length. You can also change something like the interpolation style between linear and cubic. For the scaling, you can also set the easing curve. So if you right click on this, you have some templates you can use, ease in, ease out, and all those different combinations. For now, I just leave it as is. I think it's fine. The animation is pretty short. So if we zoom in and look at it like this, it's perfectly fine as a flash animation, I think. And if you click on reset, you'll see you have the reset animation. So the use of this is that if you were to close this window right here, it stays like this, right? And it's a bit annoying because that's not how it looks by default. So for this, you can just click on the reset animation. It also plays it in the editor window, so it's just resets. That's like the purpose of this reset animation. Pretty cool. Okay, so now we need to code the logic of this RelicUI, but before we do that, the scene is still unsaved. So let's press Ctrl S to save it. And if we go back to the root folder and go to scenes, we can create a new folder for all the relics related stuff, I think. Let's press create folder, and I I created a folder for the RelicHandler and put everything related to relics in terms of scenes under this folder. So if we click OK, we can save this as RelicUI.tscn. Now the scene is saved and we can actually add code to the root node. So let's click on the plus sign to create a new script. RelicUI.gd is fine, and open this up. And before we start coding, we want to connect the signal to the RelicUI node. Can you guess which one? If we go back to 2D view, what we want to happen is when I click on the relic is to show the tooltip of that relic, right? So which signal do we need to connect? If we select the root node, RelicUI, and go to node and signals, we have this GUI input event, which we used quite a few times already. If you guess this one, then you're absolutely correct. So we connect the onGUI input event or signal to this node. And just before we jump into coding, let's be proactive for a second. If you remember, we always have trouble with like a mouse filter setting with UI nodes. So let's see if we have some trouble here. So the icon is a texture rect. If we go back to the inspector and go under mouse, we can see that the filter is set to pass, which is fine, because if it's not stopped, then it won't consume it by default. Because we connected the RelicUI, the control node's signal, to ourselves, we want the RelicUI node, this control node, the root node, to actually consume the mouse event. And fortunately for us, mouse filter is set to stop by default for control nodes. So it's perfectly fine as is, but it's always a good idea to check before you start coding and later having a trouble to debug what's wrong with the UI. Okay, so now we can go back to coding and let's see how we can do this. And because this class is just a visual representation of a relic, it will be pretty simple actually. So first thing we do is we create a custom class name called RelicUI. Then we have an export variable for the relic, which this RelicUI represents. We also provide a setter function for this to make sure that the description and the icon gets updated accordingly. Then we have two onReady variables, one for the icon texture rect and one for the animation player node. And we have to provide this setter function for the relic. And what we do is we check if the node is ready in the scene tree or not. And if not, then we wait for the ready signal. Because if you remember, setting an export variable can actually occur before the node is ready in the scene tree. That's why we need this. And again, we do two things. We override the relic property with the new one and update the icon texture rect node's texture property with the new one we have from the relic resource. And then we also provide a super simple function called flash, which does nothing else but calls the animation player's flash animation to play. And we also have some temporary code in the GUI input event callback. We check if the input event is the left mouse action button or not. And if it is a left mouse action, it means that we clicked on it. And for now, we just use a debugging print statement saying that, okay, here we should print the relic tooltip. Okay, so that's all the code we need for now. Let's save this with Control S, but in order to test this, we can also include some testing code. So for the testing code, we can do something like this in the ready callback. We can set the relic to the explosive barrel, for example, which we can preload, then create a 2-second timer, wait for it to finish, and call the flash method to see if the flash animation plays. So if we save this and test the scene by running it or pressing F6, you can see that the explosive barrel is set, it's loaded, we have that icon, and after 2 seconds, it indeed flashed. Awesome. So everything's working fine. We can get rid of this testing code and save the script with Control S. Go back to 2D view. And in order for us to test this when we add multiple relics, we can actually use one of the relics for the export variable. So for example, we can use the healing potion. For that one, we set the icon. So if I ran the scene, okay, it changes, right? Because I had the anvil icon and now I have the potion. It no longer flashes because we deleted that piece of testing code, but it works. Awesome. So that's all for the RelicUI. So now we can move on to the RelicHandler, which we'll do next. So let's click on the plus sign here to add a new scene. And this time we'll use an HBox container as a root node. So let's click on other node and search for HBox container. Let's click on this and rename it to RelicHandler. Let's zoom in a bit to see what's going on better. And we can save this immediately so we don't forget it like last time. So let's press Ctrl S. RelicHandler.tscn is perfectly fine in the scenes/RelicHandler folder. And we can change the layout of this. Set the transform to something like 120 by 16, because this will sit on the top bar. And the solution I opted here for is displaying 5 relics at the time and having like pager arrows to like navigate between the different pages of relics if you have more than 5. Okay, so let's create the node hierarchy first. So let's click on the plus sign or press Ctrl A to add a new child. And this time we'll add a texture button for the arrow buttons and double click and rename this to left button. And then we can do this because it's easier to do one and then duplicate it so we don't have to do everything twice. Or you know what, there's an alternative method. So instead, let's just duplicate it now. And I'll show you how else you can do this. So rename this to right button. Again, select the root node, the RelicHandler, click on the plus sign or press Ctrl A. And we'll add a control node as well, which will be the middle one. So let's make sure to drag this over between the two buttons. Click on this to rename it to Relics control. And under that Relics control, click on the plus sign, add another HBox container. Double click on this and rename this to Relics. So this is how it's going to look like. And under the Relics, we can instantiate with the instantiate child scene button or pressing Ctrl-Shift-A some RelicUI scenes. And if we have one, we can duplicate it a bunch of times to see how it looks like. Okay, so it looks pretty bad for now. So let's start actually setting up the nodes one by one to make sure we get the look we want. So for now, let's collapse the Relics control. We'll deal with this last. Let's start with the buttons. So if we want to edit them sort of together, since they have the same type, these are both texture buttons, right? So we can select them at once by pressing and holding Control and clicking on the other one. So if we edit the properties, we edit both of those at the same time. So what do we need to change? First of all, the stretch mode will not be keep, but instead keep aspect centered to make sure that they are centered. And we have for the texture button, we can use a bunch of textures, right? So for the normal pressed hover, we'll use the same ones. If we scroll up and go into the art folder, we have this arrow small and arrow small disable.pngs. So use the arrow small first and then sort of just drag it over. And for the disabled one, we can use a different one, which is like more transparent. And we can also check the disabled property to make sure that they are disabled by default. And I think that's all we need to change here really, except that the left button seems weird because it's not flipped. Okay, so select just the left button next and click on the flip H property. And now they look all right. You can see that something's really off because the Relics control is 0 pixels wide. And so the right button looks weird as it's not at the end, but we'll fix that soon enough. One thing we also need to do for both the buttons is to make them scene unique, so it's easy to access them from code. Right, so what do we do about this Relics control? Because it's not looking all right now. So what we do is we go to layout, set the custom minimum size on the X to 88 pixels. We come back to this how I calculated this length, but we do have these 88 pixels. And we can also enable the clip contents property. And you instantly see what this does, right? So we have more than 5 relics. And so we have a bunch of space which sort of overflows the size of this relics control. But if you enable clip contents, you can immediately see that it will clip the contents, which is exactly what we want. So we can expand the relics control and change this HBox container itself, the relics one. First of all, we want this to be a scene unique as well, so it's easy to access. And also we want to change a bunch of properties. First, we want to set the custom minimum size of this to 88 by 16. And you can see that by default, it's a lot bigger, right? So let's go to transform and reset the size. So it's just 16 pixels tall. And we also want to set the separation between them exactly. Okay, so let's go to theme overrides, constants, and set the separation to 2 pixels. And you immediately see that we have 5 relics which are perfectly fit together inside that space. So what's the math behind this? Well, all the relics are 16 by 16, right? Which means they are 16 pixels wide. If we have 5 of those, it means 5 times 16, right? Which is 80. And then we have the gap between them. So if we want to have a 2 pixel wide gap between all the relics, between 5 relics, we have 4 gaps, right? So 4 times 2 is 8, hence the 88 pixels wide custom minimum side to both this node and the relics control, right? Because we know that that's how long it needs to be. Okay, so how does this like paging option will work? So if we were to select this Relics node, you can see that if I go into move mode by pressing W and start sort of moving this container around, you can see how the pagination will work. So we just sort of have to change the, if you take a look at this part, right? We just change the X position or tween the X position of this node, the Relics HBox container, and we can sort of like scrub through all the relics. So this is why this clip contents property is a super easy way to implement this behavior. Right, and we'll do this by clicking on the buttons. For this to work, we also have to code the logic to make sure that it's only enabled if we can actually go to the next page. And then we need to handle all the tweening and all the clicking on the button related stuff. So for this reason, if you take a look at the node hierarchy now, we have like the buttons, which help with the navigation. We have this HBox container, which is probably one of the most important ones because this is where all the RelicUI nodes sit. And the reason why I included this control node, besides having a node which can clip the contents, is to actually separate the visual logic from the RelicHandler logic. Because the RelicHandler, this is not just a visual representation. We'll have methods like adding a new relic or getting a list of all the currently possessed relics and so on, which are all very gameplay related stuff. And I wanted to separate it. So it's not the RelicHandler, which has all the code that's connected to it, the visual stuff and the gameplay logic related stuff. Instead, what we do is we create all the visual stuff for the paging here under the Relics control node, and we have all the gameplay logic neatly separated inside the root node. That's the solution I opted for to make sure that the script isn't too long. Right, so I think it makes sense to start with the visual one first. So let's select the Relics control node, click on the attach script, and rename this to Relics control with snake case. Here you could argue that this could be its own scene, but as with this project, I don't really see where we would have to recreate or reuse this behavior again. This whole paginated relics container is the only place where we use this. So I don't really see the point of making this its own scene. But later down the line, if you do need to reuse this for whatever reason, you can always just save this branch as a scene, right? And come back and refactor this like we did this with Tooltips, I think, if we remember. We have the card menu UI and we have the card UI, and we had to separate those two and reuse them. So we can always come back to refactor this later down the line, but by the end of season 2, we don't use this anywhere else. So I figured it's fine to have the script here and not make this Relics control node its own scene, but you can do whatever makes sense to you. So let's press create and see how we can code the visual stuff. So we'll start by adding a custom class name called Relics control. Then we'll have 2 constants which can be set from code if we want to change them. One is called relics per page, which is 5 by default, and the other one is called tween scroll duration, and it is the amount of seconds we need to play the animation when we tween from one page to another one. Then we have two export variables for the left and the right buttons. We have two already variable references to the Relics HBox container and one to the page width, which is the length of one page of Relics, which is 88 as we know by default, but we set this from code, so it's easier to change it if you want to change the amount of Relics you display. So we just reference the custom minimum size vectors X value from the control node, the Relics control itself. Then we have some member variables, the number of Relics, which is 0 by default, the current page we're on, which is 1 by default, a max page, which is 0 by default, and a tween, which is a reference to the current tween we have. In the ready callback, what we do is we connect the left and the right buttons pressed signal to our own callback methods, which we are yet to implement. Then we connect the Relics child order changed signal to a callback, which we are again yet to implement. And we also have an update method, which is called whenever we add or remove a relic from the Relics HBox container. So we need to recalculate the number of relics we have, the max number of pages we can have, and so on. So for the number of relics, we can just get the child count of the Relics HBox container. For the max page, we need to do a calculation. We sort of just grab the number of relics we have and divide it by the relics we want to display per page. And we have a float typecasting here, but why? Well, in GDScript, if you divide two integers, then the result will be an integer as well, which is not at all what we want. Because if you think about it, if we have, 13 relics, then we divide 13 by 5, because that's the amount of relics we have in a page, and that will be 2 point something, right? And if it is greater than 2, it means that we do need a third page, right? It doesn't matter that the third page is not filled all the way up, so the division becomes 3, but we still need a third page. That's why we call ceil I when we have the fraction, because ceil I will always round up to the next integer, right? So if I have 2.25, for example, it will become 3 instead. And that's what we want. We want to have the minimum amount of pages which can cover all the way up to the number of relics we have. Then when we update, we need to set the disabled property for the left and the right button. And it depends on the current page we're at, right? So if the current page is less than or equal to 1, which is the first page, then we need to disable the left button. And if the current page is greater than or equal to the maximum page we can be at, then we need to disable the right mouse. We'll also provide a method called tween2, which is used to animate the pagination or changing the page between the relics. We have an X position as a parameter, which is the target position we want to arrive at. And what we do, and this is why we have a member variable for the tween, is we check if we have a currently valid tween, because if we do, we want to kill that tween. Why? Well, because it could happen that a previous tween is running if you're really fast, like we have 0.2 seconds for the animation, right? If this were bigger, like 0.9 or something like that, then it's easily imaginable that I click on the arrow twice or click on the right arrow, then move the mouse real quick and click on the left arrow as well. And if that happens, then we would have conflicting tweens with each other, right? Because one animation would be still playing or still tweening that property, and we want to start another one. These two lines here ensure that if we do have any tween running, then we want to kill that and do this new one because that's the latest one. So this is just a safeguard, so to speak. And then we create a new tween and set the transition and the easing to whatever we like. I use the transition back and the ease out to create like this bouncy animation effect, but you can use whatever you like. What's more important is that we tween the Relics HBox containers X position to the X position we receive as a parameter, and we use the tween scroll duration constant to set the duration of the tween animation. So then we have the callback functions. We have 3 to implement, one for the left button press, one for the right button press, and one for when the child order of the Relics HBox container changes. So what do we want to do when the left button is pressed? Well, we provide a safety check first, checking if the current page is greater than 1, because that's a requirement for us to subtract from the current page, right? If we are already on page 1, then we can go backwards. But if we're not on page 1, then we subtract 1 from the current page, called the update method, meaning we recalculate all this stuff. And then we call this tween2, right? So what we do is we take the Relics X position and add a page width to it. right? It's 88 pixels, so meaning we will jump to the next page, or the previous one in this case. And we do something really similar with the right mouse button. It's just flipped, right? We need to check if the current page is less than the max page. If it is, we add one to the current page called the update method and tween to the next page, but this time we need to subtract from the position. And another thing we want to do is the callback function or callback method for when the Relic's child order changes. And in this case, we just call the update method to make sure that the maximum amount of pages is recalculated correctly, right? Because this will be called when a new relic is added or a relic is removed or something with the children changes on this node. Right, so that's all the code we need for now. And we can actually test this if we save this with Control S and we connected this signal, but it won't be called in the ready, but we can just call it manually, right? So we can say on Relic's child order changed. And if we call this, we can test how this looks like. So let's save this with Control S. Let's go back to 2D view. And you can see that we have 12 RelicUIs in this case. If we run the scene, then we get an error message saying that invalid index pressed on base nil for the button, because if you take a look at the members, the left button and the right button is null. And these are export variables and I forgot to set them. So this is a quick lesson. I always forgot to do things like this, but we can just stop the game, go back to 2D view. That's a really easy fix. Select the Relic's control node, click on assign, select the left button, click on assign and select the right button. So now we have those export variables set correctly. Save the scene, run the scene again. Okay, so now we have no errors. And you can immediately see that our calculations work because this button is disabled. I'm on page 1 currently. If I click on those, I get the tooltip message or the debug message that we should print the tooltip. If I click on the right arrow, we change to the second page, and after the animation finishes, you can see that this button becomes enabled as well because I'm on page 2, right? If I go to page 3, we only have 2 relics here because we have 12 in total. And we can change between them. And you can see that if I click fast enough, you can see that tween.kill we just implemented, right? It starts replaying if I do it really fast. And the two tweens are not messing with each other, right? Because we killed the previous one and we just start a new one. So everything's working as intended, right? Well, almost. But if I try to close the game, something really weird happens. I get an error message. So what's this? It says that invalid set index disabled on previously freed. The weird thing about this is, why would I call the update method when I try to close the game, right? It makes no sense. So if you take a look at the stack here, this is the function that was called, right? The callback method on Relic's child order changed. And it says that it called the update. If we take a look at the member variables, we can see that the left button is still a valid object, but the right button is not. It's super weird, right? So let's rerun the scene to see if it happens again. I can still use it. Everything works fine. If I close the game, again, we have this error message for the right mouse button. So what is happening here? This is a pretty interesting problem, but it's easy to fix, but you really need to understand what's going on here before we fix it. So if you remember, we used the child order changed signal for the Relics node, right? And if you go back to 2D view and click on the Relics node, go to node and go to signals, we have child order changed here. So if I hover over it, it says emitted when the list of children is changed. This happens when child nodes are added, moved, or removed. And this is perfect for us because what we want it to do is whenever the number of relics change, it doesn't matter if it's removed or added or whatever happens, we always want to recalculate this, right? So it's good for us, but we keep getting this error. Why? Well, it's a pretty straightforward thing that happens. So when you close the game, Godot sort of starts to free all the nodes we have. If we go to the remote scene tree, you can see that at this point of the program, we only have the singletons here, the auto-loaded classes. But at this point of the program, we have a problem. And the real telling sign is that the right button is null, but the left is not. So what happens is Godot frees all the stuff from the memory, right? And if you take a look at the node hierarchy, it happens bottom up. So first of all, we start freeing all these, we free the right mouse button, and then we want to free Relic's control, right? So at this point, right button is already freed, but the left button isn't because this is between the two. That's a problem. We don't really want to calculate any of this, right, when we are quitting the game. It only makes sense to call this or bother with this at all when the game is running. So how do we deal with this? Fortunately for us, when it's considered to be null, it means that it's getting deleted from the memory. So fortunately for us, we have a way to check this. Probably this can be solved in many different ways. One that makes sense to me is to use a method called isInstanceValid. So I pull up the documentation by pressing F5, searching the help for isInstanceValid. And what this does is it returns true if the instance is a valid object, e.g. has not been deleted from the memory. Okay, so this is cool because if it returns true for both of the buttons, it means that they are not deleted, so we're still inside the game and we need to execute all of this code. So the only thing we need to do here is before we execute all this, we can just provide a safety check saying that if not isInstanceValid left button or not isInstanceValid right button, then we can return from the function because this means that we are probably trying to free everything from the memory because we don't delete these buttons ourselves from code anywhere else. And if for whatever reason they are not valid, then this probably means that Godot itself or the engine itself is freeing them because you're quitting the game. Technically speaking, we don't really have to check the left button, right? Because it's higher up in the hierarchy. So it would work the same if that's not here either, but like it doesn't really matter, I think. To me, it makes sense to check both of those, but it's not strictly needed because we saw that the right button is the only one that causes trouble here. So if you run the scene again, I can still use it just like I did before. But if I close it, I no longer get a runtime error. That's why, because this safety check works as intended and we return from the function sooner than we would try to calculate all this. Hope that makes sense. It was a learning experience for me as well when I was creating the code for this bit. And it's a good lesson to learn or to like further dive into how Godot works under the hood. Okay, so now that we're done with testing, let's not forget to delete this line of code here because we call this in order to test how this works. And also just to get rid of all the testing relics we have here, all the 12, it's a good idea to keep them here so we can see how it looks like. And if we want to change it, then we can change the appearance. But from code, it's also a good idea to delete this in the Relic callback to make sure that when we actually use it in game, we don't have 12 healing potions to start with. And we can do that like so. And I also have a really interesting piece of code here. Maybe you saw this when you see me pasting this code. It's not that complicated or different from what we usually do. Like we iterate through all the children of the Relic's HBox container. We grab all the RelicUI nodes or scenes and we delete them. But here I use free instead of queue-free. What's the reason for this? Well, in this project, I opted to not let the players stack the same relics. So you can only have one piece of each relic in the game. And we would have a really interesting problem here. If you change it to queue-free, then what happens is you queue it for deletion at the end of the frame, right? So in theory, it could happen that all these placeholder relics are still not deleted, they are just queued for deletion, and you want to add a new one. And that's exactly the case with the starter relics. So maybe we can change it to queue-free for now, and we'll come back to this bit when we actually hook up the relic system. Okay, it's always better to demonstrate, but we'll come back to this. Let's just leave a comment here, so then like fix me, so we know that we have to get back to this. Okay. But for now, that's all we need, because if we run the scene again, With F6, you can see that it's empty and all the arrows are disabled. Cool. And when we close it, there's no error message either, no runtime errors. So for now, that's fine, but we'll have a problem with this later on, as you'll see. But that's all for the visual representation. For now, we can go back to 2D view and we can do the RelicHandler itself, which handles all the logic connected to relics. So let's select the root node, click on attach script, and RelicHandler.gd is perfectly fine. Okay, so what does the RelicHandler need to do? That's the biggest script in the whole Relic system, so I'll try to explain it the best I can. First of all, let's start with a custom class name called RelicHandler. Then we'll have a signal called relics activated, and we also use the relics type to indicate what kind of relics were activated. Then we have two constants, one called RelicApply interval and one called RelicUI, which is the RelicUI scene preloaded. The RelicApply interval is the amount of seconds elapsed between the different relic activations, so they're not immediately called one after another. Then we also have two already variable references. One is called relics control and the other one is called relics. Both are nodes from our scene tree. Then we have the ready callback, where we connect the relics HBox container's child exiting tree signal to our own callback method. And child exiting tree is emitted when, you guessed it, one of the children of a given node is exiting the tree after being deleted. And I'll explain why we need this in the callback method's code itself. So then we have a method called activate relics by type, which has a parameter for a relic type. And this is like an interface or a method which we'll call, for example, from the PlayerHandler when we want to change the flow of the battle, right? So that's how it works. If the relic type is an event-based relic, we don't need to do anything because activating those relics will sort of handle themselves by connecting to that event's signal when they want to execute what they do. So we don't have to worry about event-based relics in this method, right? They are more autonomous in a sense. But for all the other ones, what we do is we call our own method, which we are yet to implement, called getAllRelicUI nodes, and we filter through them. So we only want those which match the type that we want to activate, right? For example, if we want to activate start of turn relics, we get all the RelicUI nodes and we filter them so we only have an array of start of turn RelicUIs. Then we can check if the queue is empty or not, because if it's empty, we don't really have to do anything because, for example, we don't have start of turn relics yet. And in this case, we can just say that all the relics were activated, right? Emit the signal and pass on the type we have as a parameter. In this case, basically we did nothing, but we can still say that all the relics were activated even though there were none, just to make sure that the battle flow can keep on continuing. But if they are not event-based relics and the queue is not empty, then we need to activate them one by one. So what we do is we create a new tween, loop through the relic queue, grab all the relic UIs, and call a tween callback and grab the relic UI's relic resource and call the activate relic method and bind the relic UI as an extra parameter so the relic can have access to the relic UI which it sits on. And then just to make sure that we have an interval between them so they are not immediate, we tween for the relic apply interval, which is 0.5 seconds by default. And when the tween is finished, we can emit the relic's activated signal in an anonymous function, just like we did when the queue was empty, right? But in this case, we actually wait for all the relics to do their thing, and then we can emit the relic's activated signal. So this is a pretty long method, but hopefully it makes sense what we do here. This is what we rely on in battles. So for start of turn, start of combat, end of turn, or end of combat relics, we can just call this method and it handles all the stuff we need, like filtering through them, adding them to a queue, and tweening them one by one. And we know that we have a signal we can connect to when we want to handle the logic of being finished with activating all the relics. Mind you that we still not added the behavior methods for the relic.gd resource, so when we are finished with this class, we need to go back and actually create an activate relic method because we don't have one yet. But for now, it's enough if you understand what's going on here. The next one we need to implement is a method called add relics, which takes an array of relics as a parameter, loops through them and adds them one by one. But for this to work, we actually need to implement the method called addRelic, which adds one single relic. And adding a single relic is pretty simple. First, we provide a safety check whether we have that relic already or not. So we have a hasRelic method, which again, we are yet to implement, and we pass on the ID of the relic we have. Again, this is a design decision from my side saying that we can't have the same relic twice. So this is where we sort of check for that. But if we don't have that relic, what we do is we instantiate a new RelicUI scene, add it as a child to the Relics HBox container, set the relic property to the relic we want to add, and call the initialize relic method, which is called once when a new relic is acquired. Again, we have to add this to the relic.gd script because we don't have it yet. Why do we need add relics if we have one addRelic method already? Well, we use this basically for making it easier to save and load games in the future. Because if we save all the relics we have in the save file, then when we load the game, we can just call this method and with an array of relics, and we can add them easily. We could do this like every time we need to, but it's useful to have this like handy little function which can handle an array of relics instead of just one. Okay, so how do we test if we already have a relic or not? We need to have an ID, which we want to check, and we return a Boolean, right? So what we do is we loop through all the Relic UIs by grabbing all the children of the Relics HBox container, and we check for an ID match. An interesting extra little thing here is I've included this bit of code. And is instance valid Relic UI. Why? Why do we need this? It's again a bit of a head scratcher, or can be a head scratcher. It's a lot of trouble for having the sort of placeholder relics here. Because if we go back to 2D view, we still have those 12 placeholder relics. If we didn't have those, then we wouldn't need this. But again, I just didn't want to sacrifice to have this sort of freedom to design the UI, right? Because if I can't have it, then every time I want to tweak the UI in the 2D view, I would have to tweak those settings, add 12 relics, see how it looks like, run the game, test it. And then when I'm done, I always have to delete this by hand, right? And that's just like a lot of time wasted, I think. It's always nicer if we open up the scene and we see how it looks like, right? How it would look like in game. But to handle this, we have to have this. And this is just to like avoid a nasty situation where if we go back to our relics control for a second, here we delete all these placeholder relics in the relic callback, right? So what happens is when you start a new run, you want to add the starter relic of the character, right? So these are queued for deletion. And when you want to add the starter relic, you call this method for the RelicHandler, right? And in the first line of this method, you check if you already have that relic or not. And the problem would be, you start looping through all the children and they are still there if they are just queued for deletion. They are not deleted yet. So what would happen is that this ID match would return true and your starter relic wouldn't be added to your RelicHandler. And this is not what we want at all. So by checking if that instance is also valid, we sort of say that, okay, we have that Relic UI, the IDs are matching, and that Relic UI is for sure not being deleted, right? And if it isn't, then we can be certain that, okay, we do have that relic already. I hope that makes sense. Then we also have a method called getAllRelics, which returns an array of relics from the Relic UIs. We sort of need to extract them. So what we do is we create a new array for all the relics. And we also grab the Relic UI nodes, but we are yet to implement this, but this just returns all the Relic UIs. And what we do is we loop through them one by one and append the current relic to that array and return from that method. Getting all the Relic UI nodes is an array of Relic UIs instead, and it's pretty simple. We just create a new Relic UI node and return all of those by appending the children of the Relics HBox container one by one. Okay, the one last thing we need to do here before we are finally done is to actually say what we do when the child is exiting the tree, when one Relic UI is exiting the tree. So when it's exiting the tree and it's not valid, it's null or it's being deleted, then we can return from the function because we don't want to do anything. But if it is valid and it has a relic attached to it, then we can call the deactivate relic method. Again, this is used mainly to handle event-based relics. So for example, if you have the relic called coupons, it connects to the shop entered signal. And when you enter the shop, you apply a 50% discount, right? But what happens is when you swap the relic out for a different one, then the coupons will be deleted, right? It will exit from the tree. And so you want to disconnect from that signal because whenever you enter a shop, you won't have that coupons relic anymore. So you don't want to apply the discount. So you will have this deactivate relic method for just that, for handling the case when you delete a relic from the scene tree and you want to do a one-time thing. It's basically the opposite of initializing the relic. So it's called once when you acquire it or add it to the relic handler, and deactivate will be called once when the child is exiting the scene tree, meaning you deleted it, right? Okay, so that's all we need for this one. Let's save it with Control S and see how we can test it. But actually, before we can test this, we need to add those methods or behaviors to the Relic resource script. So let's press Ctrl-Alt-O and search for relic.gd. Let's go back to this code because we only have the attributes defined, right? So it will be pretty simple what we do here, because these are only base methods, just like for statuses and cards, and they practically do nothing. So we have the initialize relic, which is called once when we add a new relic to the relic handler, and we have the owner, the RelicUI, passed as a parameter. Then we have the activate relic, which is called whenever the relic needs to be activated. And we have the deactivate relic. And for this one, I included a longer comment to make sure that you know what this is used for. If you open the project a couple of weeks later, you still remember what this does, because the other ones are quite self-explanatory. This is probably not. So we have a little comment saying that this method should be implemented by event-based relics, which connect to the event bus to make sure that they are disconnected when the relic gets removed, right? And we also have two extra methods which we'll use outside the base relic functionality, but we can still implement them now. One is for dynamic tooltips. If we want to do dynamic tooltips, we can provide a get tooltip method, a custom one, which returns a string. By default, we just return the tooltip property if you don't have any magic numbers. And we also have a longer one, which is called can appear as reward. We'll use this later on when we implement shops. So what's the deal here? Well, there are a couple rules for relics. For example, starter relics cannot appear as reward anywhere in the game, right? And also you can only see relics which are available to all characters or specifically to your character. So that's why we have a character stats resource as a parameter, so we can check for the current character. Again, we'll only use this later, but we can implement this now. It's not that complicated. If the relic we call this method on is a starter relic, then we can return false because it cannot appear as a reward. If the character type of the relic we call this on is character type.all, then we can return true because we don't really care which character we are currently playing. All of them can acquire this relic. But we have like the most complicated case when the relic is for a specific character. And what we do is we grab the relic character name based on the enum and the character name from the character stats and compare those two. And in order to do so, we take all the keys from the character type enum, which is, if we scroll up, all assassin, warrior, wizard, and grab the one which is assigned to our current character type and convert it to lowercase. So for example, if it's warrior, then this would be warrior, all lowercase, right? Then we grab the character name from the character stats resource and convert it to lowercase. And then we know for sure that both of those are lowercase and we can sort of compare them with the is equal operator, right? A small downside or like just a side note for this, we need to make sure that we use the same character names. So this should be the same as we use for the character stats resources, otherwise it won't work. These are the three we need in order to test the relic handler. So this is why I wanted to go back here. These two are just extra for future features. We can save the relics resource by pressing Ctrl S. And we can go back to RelicHandler.gd. And now we have all this code we done, but we need to test it. So in order to test it, we can add something like this inside the ready callback. We can call it the add relic method with the explosive barrel, the mana potion, and the explosive barrel again, and having like a timeout or a timer of 2 seconds between them. So what should happen here? What do you think? If everything works fine, then we should add the explosive barrel, wait for 2 seconds, add the mana potion, wait for 2 seconds, And despite the fact that we call it with the explosive barrel again, we shouldn't get a second explosive barrel, because if you remember, we have this safety check here that we can have the relic with the same ID twice. So let's see if it does what it's supposed to. So let's press Ctrl S to save it and run the scene by pressing F6 or clicking on this button. Okay, so it's kind of hard to tell if it works or not, right? Because it might be hard to tell. What happened here is for the mana potion, we didn't set an icon. So that's why we can't see if it's added or not. But, well, first of all, let's run it again. Okay. So we can always check with the remote scene tree, right? What seems to work is that we don't have 2 explosive barrels. So that's right. That's really fine. If I click on this, we get Relic Tooltip. And if I click on this empty space next to it, I also get Relic Tooltip. So it's probably there, right? But we can always check with the remote scene tree. Under Relics, we have 2. So we have this one, the explosive barrel, and this one with the mana potion, the TRES, but we just have no icon assigned to it. Right. If I change this to healing potion instead, then it should add it after 2 seconds. Yeah, and the icon appears this time because we have set one for this. Okay, so it seems like the Relic handler is done. Again, I know that this is a lot of code you need to absorb, but the functionality itself is not that difficult, I think, like getting all the relics or checking if we have one. But we have some small nuances, like this is instance valid. And also this is the big one that we'll need when we hook it up in the battle, actually activating the relics based on their types. Okay, so that was a lot of coding, but it works. Everything's fine for now. We can delete these pieces of code which we used to test it. And we can save RelicHandler.gd with Ctrl S and move on to actually coding the relics and implementing them, adding them to the game by hooking it up in the systems where we need to. If you like my content, please consider checking out my Ko-fi page where you can donate one time or become a member and get early access to all my content and videos. So the next thing we want to do is to hook up this whole system inside the run scene. So let's go back to 2D view. Press Ctrl-Shift-O to quick open a scene and search for run.tscn. And here you can see that we already have this big space, which we can use to instantiate our Relic handler. So let's select this placeholder we have here, right click on it, and change its type to a center container. So we can make sure that the Relic handler itself will be centered inside this space. And we can maybe rename this to Relic handler container or something like that. And if we select this and click on the instantiate child scene, we can search for RelicHandler.tscn. And you can see that we have a problem because it's slightly smaller than it's supposed to be. So if we go to layout and transform, you can see that it's just 12 pixels on the Y, which is not that good because it should be 16. But we can quickly fix this if we set a custom minimum size of 16 pixels. And now we're good to go. We have 1 pixel at the bottom and the top because the top bar itself is 18 pixels tall and it's perfectly centered inside that space we have. We can also right click on this and make sure that we can access it as a scene unique name. This way it's easy to hook it up with code. And we don't really need anything else to do here. We're perfectly fine. So how do we hook this up in code? Let's go to the script of our run scene and see what we need to do here. So first of all, we need to have a reference to our Relic handler so we can use it in the run itself. And as we talked about it in the architecture overview, we also need to inject it as a dependency to different scenes. So what we do is we grab another already variable reference. We call this the Relic handler, and this is why we needed that scene unique name. So what else do we need? Well, when we start a new run, we want to add the starting relic to the player, right? So let's click on the start run method in the left panel. And we can see that inside this start run method, we have a method called setup top bar. If I press and hold Control and click on this, this is where we set up everything inside the top bar. We have the gold UI, deck button, deck view, all that stuff. So we can just sort of make sure that the order is consistent to the order of the elements in the UI itself. We have the health, we have the gold, and then after the gold, but before the deck view, we have our relic handler. So here we can just do something like this. Relic handler.add relic character that's starting relic. Pretty easy, right? And for now, that's all we really need, because yeah, we need to hook it up in the battle and like inject that dependency, but we'll come back to this script when we actually start managing the battle. So now we can save this and test if it works or not. So if we run this scene at the run scene or press F6, what happens is we don't have the starting relic added, right? Why? Well, if you remember, I used some foreshadowing. What happens is, if we go back to RelicHandler.gd, and also we need the script for the relics control, so let's press Ctrl+O and search for relics control.gd. Remember this little fix me here? So here's what happens. I kind of want to show you. If we go back to run.gd, we can just add a breakpoint, right? And if we run the game again, or run the scene, what happens is when you add the breakpoint, the debugger will stop at the execution of that point. At this point of time, we call the add relic method, right? And we want to add the character starting relic. So let's check a couple of things. First of all, if we go to the remote scene tree, use the top bar here, have the bar items, the relic handler, and under the relic handler, we still have those 12 here. You can see that, right? And we should delete those because we have the code to delete them. It's right here. See, the problem is Q3 deletes them at the end of the frame. So you can see that they are still here by the time we arrive at this add relic call. So what happens here? We grab the character resources starting relic. So what do we have inside character? If we click on this one, you can see that the starting relic is healing potion.tres, right? It's right here. Okay, if we click on any of these relic UIs, which are still here, they do have the healing potion connected to them. So what happens is when we call add relic, we can actually step into this, right? And that's the interesting bit. So we have the relic, which is the healing potion, which we want to add. And we call this hasRelic method, right? So just step into it. And if we step into it, we loop through all the relic UIs we have, right? And get all the children and check for the ID match and see if the instance is valid. Well, the relic UI we have has the healing potion. And the relic I want to add is the healing potion, right? The ID is healing potion. And the ID for that resource is also healing potion. So what we do is, well, is instance is valid because we still haven't started deleting those nodes. We just queued them for deletion at the end of the frame. So hasRelic will return true. And we return from this method earlier than we need to, right? We don't add it. And if we go back to this, we can see that these are still here. And if I say that I continue the execution of the program, what happens is at the end of that frame, all the relics get deleted with Q3, but I haven't added the starter relic because when I tried to edit, all of those nodes were still there. So how do we fix this? Well, let's just remove this breakpoint for now. But you know what? It can stay there so we can test our solution. If we go back to relics control, we have this fix me here. And we can use something else instead of Q3, namely free. So what's the difference between those two? If we press F1 to open up the documentation, we can search for free. And you can see that it deletes the object from memory. Pre-existing references to that object become invalid, and any attempt to access them will result in a runtime error. You can check those references with is instance valid, and they will return false. And this is exactly what we were talking about with is instance valid. So when a node is being deleted, you can still have references to it. So generally speaking, like 99% of the time, you want to use Q3 instead because it's much safer. The Q3 is just queuing the node to be deleted at the end of the current frame. When deleted, all of its children are deleted as well, and all references to the node and children become invalid. Unlike with free, it's not deleted instantly, and it can still be accessed before deletion. you can check this with queued for deletion. Okay, so you can see that we have like is queued for deletion with which we can check. So we have multiple ways to solve this. One is to keep using queue-free. And instead in the RelicHandler for the hasRelic method, we can say that we only need to match those IDs if that RelicUI is not queued for deletion. Or the other thing we can do is to use free instead. So generally speaking, this is like much less safe to use. But if we go back to RelicHandler, that's why we have this is instance valid, right? Because the doc said that this will become false when the reference is no longer existent or valid. So this is why I included this one. But we can also just keep using queue-free and change this to RelicUI.is queued for deletion to check if it's queued for deletion. But we can use free just to sort of show you how you can use free as well sometimes. But then we need this to make sure that it's a valid instance, not something that's already deleted and is just a hanging reference. So if we save this, the only thing we changed is changing queue-free to free in this case, which deletes it immediately. So if we go back to run.gd, we still have the breakpoint, right? So let's run it again. We arrive at the breakpoint. And now if I were to show you the remote scene tree, you can see that the relics is empty by the time we arrive here. Why? Well, because we deleted them instantly with free. And it's called sooner than we start like setting up the top bar and stuff, because the run is way above in the hierarchy, right? So we deleted all the relics instantly. And now if we continue to run the game, our health potion appears. Hopefully you learned something with this. And for now, that's all we need to do in the run to hook this up. We need to like have this starting relic and just instantiate it up here. So if we click on this and I move from the debugger to the output, you can see that the relic tooltip placeholder still works. So we still have access to everything we need to. It's just now we handle correctly deleting those placeholder relics inside that relic handler. So if we stop the game, we can remove this breakpoint by clicking on it again. And we can move on to hooking this up inside the battle scene. So we can move on to hooking this whole thing up inside the battle itself. So let's press Ctrl-Alt-O and search for battle.gd. And let's see what we need to change here. So the first thing we need to do is to grab a new variable and let's call it relics, which is a relic handler. And we can provide it as an export variable if you want to test it somehow from this scene. But generally speaking, we will inject this dependency from the run itself, right? So let's not forget to do this when we are done with this code to actually test it. What else do we need here? So when we start a new battle, what we do now is we do all sorts of setup. So we start playing the music, right? Do the setup things for the enemy handler. And then we call the start battle function from the player handler and initialize the card panel UI. Now that won't do it anymore. Why? Well, because if you remember, we have start of combat relics now. So how this will look like is we'll execute all the start of combat relics first, and then we do all this stuff. So instead what we do is we connect the relic handler's relics activated signal to our own callback method, which we are yet to implement. And also after establishing that connection, we call the activate relics by type, and we activate all the start of combat type relics. If you remember, this was the pretty long method we implemented here, where we check for its event base, then we do all the filtering, then we check if it's empty, and if it's not, then we activate them one by one, applying a 0.5 seconds interval. And crucially, even if it's empty or if it's not empty, either way, we emit this signal, right? That the relics were activated. So we connect to that signal, which is really important. But also when we start a battle, we start by actually activating all those start of combat relics. But we just overwritten those two lines of code, which start the battle from the player handler and initializes the battle UI. And we also need those, just not here, right? Another change to this flow is this one. So we are connected to the enemy's child order change signal. And when the enemy handler has 0 children, then we emit this signal, right? That we requested the battle over screen. Well, we have to do this, but not here anymore. Instead, what we do is we activate all the end of combat type relics when there are no enemies left. And once those relics are all activated, then we can move on to the victory screen. The same here. When all the start of combat relics are activated, then we can move on to actually setting up the player handler, drawing the cards and all that good stuff. But now we need to implement this on relics activated callback method because we don't have one yet, right? So we can do this right here, and it works like this. When the relics were activated, we have the type saying that which kind of relics were activated this time. We match that type, and if it was a start of combat relics, then we do those 2 lines of code we did in the start battle method before, right? So when all the start of combat relics were activated, then after that we can call the player handler start battle and then initialize the Spire-style. Same for the end of combat relics. When all the end of combat type relics were activated, then we can request that victorious battle over screen. Pretty cool. So that's all we need to hook this up right here. Again, just to walk you through this, we have an export variable which we need to inject from the run. Then inside the start battle, we replace those 2 lines of code by connecting to that relics activated signal and also activating the start of combat relics. Then when all the enemies are dead, we activate the end of combat relics, and inside that on relics activated callback method, we see what kind of relics were activated this time, and if it was start of combat, then we can continue like we did before, calling the player handler's start battle and the initialize Spire-style. But if it was all the end of combat relics which were activated, then we can emit the battle over screen requested signal. So let's save this, and to test this, we actually need to inject the RelicHandler dependency, right? Because if I were to run it now and move on to a battle, we get an error message that we can't connect the relics to the relics activated signal because the relics is it's an export variable which is not set, right? And that's perfectly fine because we said that we want to inject this dependency from the run when we move on to a battle. And injecting this dependency is not that difficult. We have this callback method called onBattleRoomEntered, and when we enter a battle room, we change the view to the battle scene and inject some dependencies anyways. So we just need a new line here saying that the battle scene's relics property should be equal to our relic handler. And with that little change, if we save this and test the scene again, and go into a battle, everything works just like it has before, which is a good sign, right? We don't have start of combat relics, so nothing happens really, but I still draw my cards. The UI is still initialized. I can still use everything and I can still play the battle. So we didn't break anything, which is always a very good sign, right? So in theory, it works, but it's kind of hard to test this without testing it properly with the working relic. So we'll actually code the next working relic, but oh, did you see that? We have some sort of a problem. Let's run the game again. What happens here? So if I start the game, start battle, I drew my cards, and if I close the game, oh, I have a runtime error when I try to close the game. Okay, what happens here? Again, we have this enemy's child order changed. And if you remember, the child order changed signal is emitted even when I close the game, right? Because Godot starts deleting all those scenes. So we didn't have an error here before, and the reason why is we use the events singleton, right? We wanted to emit a signal from the events singleton. And singletons are always kept in the memory, or auto loads, in Godot's case, are always kept in the memory, so you can always reference them, right? But here, not anymore, because relics is not a singleton, it's actually a node in the scene tree, in the hierarchy, right? So you can see the filter stack variables here that the battle UI becomes null, the player handler becomes null, the player becomes null, and the relics too. So as we close the game, Godot starts freeing all those allocated memory spaces for us. So that's a problem, but we already know how to fix this, right? It's pretty easy to do so. We can just say that, yes, the enemy's child count is 0 now, and the relics is still a valid instance, not something that is being deleted from the memory. And with this little change, okay, I drew my cards, I close the game, you can see that it prevents from this runtime error. I know that it's kind of tedious to do this, but again, you could like circumvent this if you don't rely on the enemy's child order changed signal, but I think it's convenient, right? Because this is emitted both when we add new children and both when we remove children from the scene tree. So it's perfect for this case, but if you use this, you have to keep this in mind, right? So you either use this or opt for like manually checking the child count or emitting a signal when it reaches 0 or something like that. I just kind of wanted to show you because it gives you like a glimpse how Godot works under the hood, I think. Okay, so that's it for hooking this up inside the battle, and we'll see how we can actually code and implement one relic next. Okay, so to test this whole system we built, why not create our first real relic and see it in action? So to do this, let's go back to 2D view, and we can collapse the art folder for now. And if we scroll all the way down, we have our script templates folder. Since we have to script all the relics individually, it's a good idea to create a new template for the relics as well. We have one for statuses, enemy actions, effects, and cards too. So right click on the node folder and create a new script. Let's call this relic_template.gd, press create, and double click to open it up in the script editor. And first of all, we'll provide the metadata to this class so the editor can have access to the name of the template and the description. Then we provide an example for declaring a member variable. And then comes the most important part where we override all the behavior, all the functions which we can implement on a per relic basis. So first of all, we have the initialize relic method, which happens once when we obtain a new relic. Then we have the activate relic method, which happens at specific times based on the relic's type, right? So for example, for end of combat relics, this method gets called, well, at the end of every combat once. For start of turn relics, this method gets called at the beginning of every turn, and so on. This is where we need to do all the main logic for those kind of relics. Then we have the deactivate relic method, which again is called once when the RelicUI is exiting a scene tree, which means it's getting deleted. So event-based relics basically can disconnect from the event bus here if they need to. And last but not least, we have an optional method called getTooltip, which returns a string if we want to use magic numbers, or if we want to replace some part of the original tooltip, we can provide it on a per relic basis. But again, if we don't, then it will just use the tooltip property, which is a BB code string. So that's all we really need for this template, and we can save it with Ctrl S. So now we can create the actual code for our warrior starting relic, which is the healing potion. So let's go back to 2D view. And we can collapse the script templates in the file system for now. And if we go to relics, our new folder, we can right click, create a new script. Let's call this healing potion.gd. This time we actually want to use a template. So let's enable the templates and select our relic template here. And you can see that we have our metadata correctly displaying. And we can also make sure that it inherits not the node class, but the relic class instead, but we don't really need to override this. It doesn't really matter because we already have that defined inside the template, right? So we can just press create, double click this, and we have the extends relic keyword here. So we have all that stuff available to us from the template, but we can actually get rid of anything we don't need. So we only need the activate relic method in this case, nothing else. And we can also change this underscore owner to owner without the underscore, indicating that we actually do use this parameter. And let's see how we can implement healing 6 at the end of the combat or the battle. Well, it's pretty simple actually. So we have to grab a reference to the player, and this is tricky in the case of relics because relics live outside the battle itself, right? So we don't really have access directly to the battle, but we do have access to our owner, which lives inside the scene tree because it's a RelicUI, it's a control node. So we can call get3, right? We couldn't do this without the owner dot because resources, and this is a resource script, resources live in the file system, not in the game's scene tree. So we had to do owner.get3, and I opted to use groups in this case because we already have groups set up, right? The player is inside the player group and all the enemies are inside the enemy group. So what I do is I get a reference to the scene tree, and the scene tree has a method called getFirstNodeInGroup. So we get the first node in group from the player group. We cast it to a player, so we have IntelliSense or auto completion with the asPlayer keyword. And just to make sure, we do provide a safety check here that the player exists, it's a valid object inside the scene tree. And if it is, we do two things. We call the player stats, the character stats resources heal method with the number 6. And we call owner.flash, and owner is the RelicUI itself. So if you remember, inside the RelicUI class, we can just press and hold control and click on this. So remember, this is where we play the animation to flash that relic, right? And also we have this heal method. 6 is inserted here if you want to make your code a bit cleaner or make it even an export variable. You can do something like this just to show you. We can do export variable heal amount, and we can make it 6 by default. And instead of hard coding this value here, we could do heal amount like this. Pretty simple, right? It's like 4 lines of code basically. And one cool thing about this is this activate relic method will be called when it's needed to, right? In the case of end of combat relics. Because if you remember, we just changed battle.gd, right? So if we go back, this is the method we need to look at, right? So whenever the enemy handler's child count is 0 and we have a valid instance of a relic handler, we activate all the relics by the type of end of combat relics. And you can see kind of how it all comes together now. If we press and hold control and click on this activate relics by type method, you can see that in this case, we will not return immediately because it's end of combat, not event based. Then we'll grab and filter all the relics we currently possess, which are end of combat types. In the case of the player, there will be one, this healing potion. So this piece of code won't be executed, right? Because it's not empty, we do have one relic. So what we do is we loop through that array, which will only have one specific relic, that healing potion, and we call this activate relic method. So by hooking it up correctly in the different systems, we already handle all the logic we need to. In the relic itself, we just really need to define what it does. And by selecting that end of combat type, it will automatically be activated at the end of each combat. Pretty awesome. So that's all we really need to do. We can save this with Ctrl S, go back to 2D view, and this is a really important step. Many of you forget to do it and then leave comments why it doesn't work. So I just kind of want to drive your attention to this. So it's not enough to code it, right? We have to double click on the resource because currently this resource uses the relic.gd script, and that's the base one. So if I click on this, you can see that we do have the methods, right? The activate relic, initialize relic, deactivate. But we only have a pass statement here, so it does nothing by default. So if you do all the steps, you have the code, you have the relic and everything, but nothing happens, it's probably because you forgot to change the script. So what we need to do is we need to select, double click the healing potion relic resource itself, so it shows up in the inspector, and change the script. So grab this healing potion.gd and drag it over this. If you remember, this resets the icon, but it's no biggie. We can reload this like so. And you see, since I provided an export variable, we don't even have to tweak the code. If we don't want to, we can just change the amount that relic heals right from the inspector. But for now, we can leave it at 6. We save everything with Ctrl S. Then we should be able to test this relic in action. So let's start a new run. We have the relic, right? So far so good. And if we go into a battle, okay, it's perfect. I can lose some HP to show you how it works. Okay, I lost a bunch of HP. I'm at 16 out of 35. And now if I win the battle, see what happens. I healed for 6. Because now I'm at 22, and if you watch the Relic UI carefully, it did flash. That's all we really need to do for creating relics, at least for the start of combat and end of combat relics, because we still didn't handle actually doing it on a per turn basis, right? But for now, let's create the other one, which is for the start of combat, the mana potion. So what the mana potion does, if we double click it, we have the description: at the start of combat, gain 1 mana. Cool. So it should be pretty simple or easy to do this based on this one. So let's right click the Relics folder, create a new script, call it manapotion.gd, use the Relic template, double click to open it up in the editor. And we really only need the activate relic again, right? So we can delete everything else. And this time we can do a separate method, and you'll see why in a sec. And in this separate method, we'll add mana. So what we do is we flash the relic again, just to sort of provide a visual indicator that the relic was used. Then we grab the player, same thing we did before. And if we have a legit player, then we access the stats and add one to the mana of the player. Pretty straightforward, right? So the first version we do this is we just call this in the activate relic method and say we want to add mana to the owner. And let's not forget that this has an underscore by default. And if we do end up using it, then we need to delete that underscore. Cool. That's it. That's the first version. And we can save this with Control S. Again, let's not forget to actually assign the script. So let's go back to 2D mode, double click on manapotion.tres and drag over the script file for this slot, right? And that's why I haven't set the icon for this one, because I know that it would disappear. So let's go to the art folder, select the manapotion. Okay, to test this, we can do multiple things. Probably the easiest one is to change the starter relic for the warrior, right? So let's search in the file system for warrior.tres. So double click on warrior.tres. And if we clear the filters, scroll back down, we can drag over the mana potion like so. And we replaced it. Cool. So now if we save it Control S and run the game again, we have the mana potion as a starting relic. And if we start a new battle, watch closely what happens. Did you see that? So what happened is it did what it said it does, right? It flashed the mana potion. My mana was 4. But then before I started drawing my hand, it actually went back to 3. Why is that? What happened here? Let's open up the battle scene and investigate. So press Ctrl-Shift-O and search for battle.tscn. And here we can actually open the script. We don't really need the scene. So click on the script icon here and let's investigate. So when we start the battle, we start by activating all the start of combat relics, right? This is where our mana potion flashes and adds 1 to our mana. What happens after that? So we have our callback method called onRelics activated. And when all the start of combat relics were activated, we do this. We call the PlayerHandler's start battle method. Let's press and hold Control and click on this one. Okay, so what do? We create a draw pile, discard pile. So these shouldn't really alter how many mana points we have, right? But then we call this start turn method. And what happens in this start turn method, now you can see where the problem lies, right? At the start of every turn, we reset the mana and the block for the character. Okay, so that's a problem, right? Because when we go back to the battle, what happens is this happens sooner than actually starting your battle from the player handler's side. So we do have that 4 mana temporarily, but then we reset it. So let me show you again, just to make sure that you see what happens, not by running the battle scene, but by running the game itself. If I click on this, watch closely, 4, it flashes and goes back to 3. So now we know where the problem lies. Question is, how do we solve it? Well, we can do multiple things. Let me tell you about 3 possible solutions. Okay. So another solution, which is probably super useful in the long run, but for the sake of this example or this course, I don't want to pollute the whole architecture or the event bus of the game. In practice, if you were to do a game like this, you probably want to have more fragmented or nuanced events. So right now what we have is hand drawn. Let's open up the events.gd file. Okay. So we have some events which are related to the player. For example, player hand drawn, discarded, player turn ended. player hit, player died. We could fragment this or like do more nuanced events. So for example, we could do something like player turn started, or we could have events for everything. So player turn started, player start of combat relics activated, or before player start of combat relics activated, after player start of combat relics activated, and things like that. So one solution is to like split all those into two different ones, before and after, right? And that's what the original game does basically. So you have much more fragmented events, so it's easy to sequence them, right? So you could say that you want to do this after a player turn resetted or something like that. So if you have an event for this, when you reset the block and the mana, then it's easy to connect to that event. The reason I don't want to do this, I think that's probably the cleanest solution, but this project is complicated enough as is. So for the sake of the example and learning, I want to keep this as simple as possible and not do like 30 or 40 events for everything. In reality though, it's probably a good idea. So that's the solution I would go for in a commercial game. So that's the good solution I would do. What about the hacky one I opt for here? Since we do have an event called player hand drawn, we know that the player hand will be drawn after resetting the block and the mana. How do we know this? Well, because of the player handler. So you can see that what we do is we reset this, and then we apply the statuses, right? And when the statuses are applied, after all the start of turn statuses, we'll draw our cards. So this will happen only after resetting the block and the mana. So without like further fragmenting these events into many more events, we can just connect to this player hand drawn and say that only add one to the mana after the player hand was drawn. So that's a bit hacky, I know, but it saves us a lot of trouble from overcomplicating the project and keeping it simple for the sake of learning. So how do we do this? We go back to the mana potion. Again, it's a good learning experience, and there's something really useful which you can learn with this hacky solution. So instead of just calling this when we activate the relic, we can say that we connect to the player hand drawn signal, and when it happens, we call this add mana method, and we bind the owner to make sure that we receive the owner so we can flash it. And it's something we haven't really done yet, I think, is we pass another parameter to the connect method. So what this connect one shot does is it makes sure that this method can only be called once, and then it automatically disconnects this method from the signal, which is pretty cool because we don't want to do this every turn where the player hand is drawn. We only want to do this once at the start of the combat. So when the combat starts, we connect this signal, but we also specify that this is a one-shot connection. So when the event actually occurs, we execute this method and then automatically disconnect from the signal. So with this little change or hacky little solution, we can actually solve the problem. So if we save this with Control S and run the game again, you'll see that I have 3 mana, I draw my cards, and then when the hand is drawn, the relic flashes and I get 4 mana. An interesting thing we need to test is what happens when we actually end our turn and go to the next one. And you see no flash and no mana increase when I drew my hand. Because connect one shot, again, only connects the event to the method once and then automatically disconnects it. Pretty cool. So that's it for the mana potion. And we'll do the explosive barrel next. Okay, so we want to do the end of turn and start of turn relics first, the explosive barrel and the reinforced armor. But before we can jump into coding the relics themselves, we need to accommodate the player handler to the flow changes first for the last time. Because we no longer only do statuses, we also do relics, right? So let's press Ctrl+Alt+O and search for PlayerHandler.gd. And here I think it's probably useful to have some extra lines of comments to remind us if we want to change anything in the player handler about this flow. So I included something like this. You know, when you open up this file, the first thing you see is this. It's sort of like a summary of that battle flow architecture diagram we seen in the beginning of the video. So we start with start of turn relics, then statuses, draw the hand and the turn, end of turn relics, end of turn statuses, and then we discard the hand. It's pretty useful to have this overview in code, even if it means having 8 extra lines of comments, I think. If you don't need this, then you can delete it for sure. Okay, what else we need to do? Well, we need a new dependency, right? Having the RelicHandler, which will again inject as a dependency not from the run itself, but the battle, right? So the run has the RelicHandler, it injected that dependency to the battle, and the battle will further inject that dependency to the PlayerHandler. So let's not forget to go back to the battle.gd script to actually assign this value when we're finished. What else do we need to change here? When we scroll down, we have this start battle method, which we call once when the battle is started. So to accommodate to these flow changes, we need to have a callback method when we are finished with activating all the relics with a specific type. So somewhere here, we can do something like relics.relicsActivated.connect on relics activated. We have this error message because we are yet to implement this callback method, but we'll do it in a second. And again, we do something really similar to what we did with the battle itself, but there we sort of substituted the old logic with start of combat and end of combat relics. And we do the same, but with start of turn and end of turn relics. So again, when we have this start turn method, we reset the mana and change the block to 0. And instead of starting with applying the start of turn status effects, we'll start by activating the relics first. And we do a pretty similar thing when we end the turn, right? We would start applying the end of turn statuses. Well, not anymore. Instead, we activate the end of turn relics first. And to sort of make sure that this chain doesn't break, we have to provide this callback method and say, okay, when the start of turn relics are all activated, then we can move on to the start of turn statuses. And by re-establishing that link, that chain of events, then everything else will work. So we can scroll all the way down and create that new callback method. And what we do with that callback method is we say that, okay, we match the type, what kind of relics were activated, and if they were start of turn relics, then we can start applying the start of turn statuses. And in the case of end of turn relics, we can start applying the end of turn statuses. And we don't really need anything else because above this method, we have this callback for when the statuses are finished applying, right? And that's what I meant by fixing the chain of events. So when I have all of the start of turn relics finished, they are all activated, then I start applying the statuses. And when the statuses are applied, then I start drawing my cards. The same with the end of turn. I activated all of my end of turn relics, then I start applying the end of turn statuses, and when those are finished, I start discarding my cards. So with these changes, we accommodated the PlayerHandler to that new flow of events. Again, just to reiterate, let me walk you through the whole thing again. So this is the order we want to provide. Start of turn relics, then the statuses, then the card draw, and for the end of turn, we want the end of turn relics, then the statuses, then discarding the remaining cards. So the way we implemented this is we ask for an outside dependency saying that we need to have access to the RelicHandler, which will inject again from the battle.gd script. And then when we start a battle, we need to connect the relics activated signal to our own callback method. And when we start the turn, here instead of applying the start of turn statuses, we start with our start of turn relics, right? And similarly, when we end the turn, we disable the hand, and instead of moving on to the end of turn statuses, we move on to the end of turn relics first. And then and only then, in this callback method at the very bottom, when we're finished with the start of turn relics, then we move to the start of turn statuses, after which we can start drawing the cards. And in a similar fashion, when we have all the end of turn relics activated, we move on to the end of turn statuses. And only when all those statuses are applied to, then we start discarding our remaining hand. Hope it makes sense. So that's all we need from the PlayerHandler script. We can save this with Ctrl S. And now we could start doing the explosive barrel and the reinforced armor, but let's not forget to inject that dependency, right? This one, we still don't have access to the RelicHandler yet. So let's press Ctrl-Alt-O and search for battle.gd. And in battle.gd, we do have a method called start battle. And in the start battle method, we do all kinds of setup things for the enemy handler as well. So here we can just say something like PlayerHandler.relics equals relics, because at this point, we already have the relics injected from the run. Right, so it's always a good idea when you disrupt this flow of events to test everything before even jumping into creating relics. So if we save this and start a new run, then we should be able to play the battle just like we did before. Okay, so I get my extra mana here. I can attack the crab enemy. He executes his action and everything seems to work fine, right? I can draw my cards, I can still play the cards, everything works perfect. Okay, so the flow is still intact, the chain seems like it's working, it's just we don't have any relics that would do their thing at the start or at the end of the turn. So now we can actually move on to creating those relics. So let's start with the explosive barrel. Let's go back to 2D view and in our relics folder, right click, create a new script. Call this explosivebarrel.gd. Click on create and double click to open this up in the editor. We can delete everything we don't need. We only need the activate relic method in this case. And instead of this member variable, we can create a new export variable again to make sure that it's easy to edit from the editor. We can call this damage and make sure it's equal to 2 by default. And inside the activate relic itself, it's pretty easy what we need to do. This time we'll actually want to get the enemies group, right? And all of those, not just the first one. Oh, and by the way, we have this error message because I forgot to delete the underscore from the owner. Now it looks fine. Okay, so we grab the enemies and we use owner.getTree and get nodes in group. Then we create a new damage effect. We set the amount to the damage we have in the export variable, execute it, and then flash the owner, right? Pretty straightforward. Let's save this with Control S. And if we go back to 2D view, you know the drill by now. We cannot forget assigning that script to the resource. I can't emphasize this enough because it's so easy to forget this. So let's drag this over and replace the script, right? Then we have the damage export variable and we need to reassign the icon, but no big deal. We do that and we can test this. Again, probably the easiest way to do this is to set it as a starting relic. To do so, we search for warrior again, clear the filter, and just drag over the explosive barrel to the starting relic slot. If we play the game again, you see that we have our explosive barrel icon here, and indeed that crab took 2 damage. Pretty awesome. So if we play one more turn, you'll see something weird here, right? So if I end my turn, the next turn should start by the crab taking damage again, right? So it should go to 17. But what happens is it goes to 16. So why did the barrel deal 3 damage instead of 2? Well, it's no coincidence, I can tell you that much. So I on purpose played this card in the previous turn, which leaves the exposed status effect on the enemy, which means it takes 50% more damage, right? So I left out a bit of code on purpose to show you this. So you probably don't want your relics to deal increased damage based on this exposed status, as this should only apply to attacks, right? So how do we solve this? And I just wanted to show you this because we already solved this problem back when we implemented statuses and modifiers. I just wanted to show you how handy it can be later on. So if we go back to the script, take a look at how damage effect works. So let's press and hold Control and click on the damage effect class. And you see that we sort of set up this member variable called receiver modifier type, which is by default damage taken. So when we call the target's take damage method, we say that, okay, this amount should be modified by the damage taken modifier. Well, this is fine in most cases, but for the explosive barrel, we don't actually want to use a modifier. So what we can do is in here, that's why we created a special type of modifier. So we can say this damage effects receiver modifier type should be overwritten with this no modifier enum value. And if that's the case, then the exposed status will no longer affect the damage of the explosive barrel, which is pretty cool. And we can still use the damage effect to deal damage. It's just we need to sort of tweak it to our own liking, which is in this case that it should ignore all the modifiers that are present on the enemy. Super awesome. So if we play the game now, let me try to recreate that scenario. Okay, perfect. So it dealt 2 damage, right? Let me draw my card here, not yet. Okay, now I have it. So if I use this one, you'll see that it has 21 HP and it wants to gain 6 block. At the start of my turn, even though it has the exposed status, the barrel still did only 2 damage, right? quick fix. Our systems are super flexible, and that's exactly what we wanted. Awesome. So that's it for the explosive barrel. We can move on to the reinforced armor next. It won't be that difficult either. So let's go back to 2D view. Right click on the Relics folder, create a new script, call this reinforced armor.gd. Double click to open it up. And again, we can delete everything we don't need. We don't need a special tooltip. We don't need to deactivate this relic. We don't need to initialize it. And we can, again, provide a custom export variable, call this block bonus or something like that. Maybe say that it gives 3 bonus block. And what we do is pretty straightforward at the end of each turn. Again, let's not forget to remove the underscore here. And what we do is we get the owner, the RelicUI, and we get the scene tree from it. And you might notice that I use get nodes in group here instead of get first node in group. Why? Well, because we create a block effect, right? To add the block bonus. So we create a new block effect, set the amount to the bonus, and then execute it. And if you take a look at the execute method itself, which is used for effects or the block effect, it wants an array of nodes, right? Even if you only have one target. So it's easier to just use get nodes in group because it wants an array anyways, right? So we grab all the nodes in the group, even though it only has one, create a new block effect, set the amount, execute it, and flash the relic itself. That's it. We can save this with Control S. And also, if we go back to 2D view, again, I know you probably are bored by this by now, but it doesn't matter. We still need to do it. So let's not forget to assign it. So double click on reinforced armor. Drag the script to the script tab to make sure that it doesn't use the default relic script. Okay, we have a new export variable here again, the icon reset. So we set it again to this anvil, and that's it. We can save this. And to test it, probably the easiest way again is to change the starting relic. So search for warrior, go back to the file system and drag the reinforced armor over the starting relic slot, and we can play the game. Start a new battle. Okay, I use 1 block card, so I have 5 block. And if I end my turn, it goes up to 8. And you can see that it happens before I start discarding my cards, right? And that's perfectly fine because what we do is relics first, then the statuses, and then discarding my hand. Awesome. So everything works as intended. I can use end of turn relics as well. The only one we didn't touch is the event-based relics, but we'll come back to that in the next video, because when we implement the shops and the treasure rooms, then we will implement the coupons relic as well. So we can see how that looks like. For now, that's all the relics we wanted, but we still have one big feature missing, namely the tooltips of the relics, right? So the player right now doesn't really have a way to check what each relic does. They can only guess based on the icon. So we still need to provide a way for them to display the relic tooltips. And for those tooltips, I wanted to go with the easiest possible solution, so it will be pretty similar to how tooltip pop-ups work in the game, making sure that we can reuse as much as possible from those already existing scenes. So let's press Ctrl-Shift-O and search for card tooltip popup.tscn. If you look at this, it's pretty similar to what we want to do with relics. Instead, the card menu UI, we just want to have an icon here and we want the description under it. Maybe a back button at the top right corner of the screen, and that's all we really need. So to make sure that we don't screw with this one, which is already working properly, we go to Scene and save Scene as with Ctrl-Shift-S. Go back a folder, and we can save this next to the other RelicHandler scenes. So go to the RelicHandler script, and let's call this relic_tooltip.tscn. And we can start by changing this up the way we want to. So first of all, we can delete the card menu UI because we don't need that. Then we can rename the root node to Relic Tooltip by double clicking on it. We can detach the script from the node with this button because we want a new script. And you can see that a signal is also connected to it. So if we go to the node tab, we can right click on this GUI input signal and say disconnect. So we have this tooltip card here, which is a center container. We don't really need a center container anymore for this. We just want to display an icon here. So let's right click on this and change type and search for texture rect. And while we're here, we can rename this to relic icon. And to see how this would look like, let's go back to the inspector here and load one of those textures. I don't know, maybe the barrel. And it looks pretty bad. So let's change the stretch mode to keep us back centered. And under layout and transform, we do have the correct size, but just to make sure, we can set the minimum size to 16 by 16. And we can also rename the card description node. We don't really have to change anything. We just rename this to Relic Tooltip. Maybe we can change the placeholder text if we want to something like Relic Tooltip. And yeah, copy this over a couple of times, like so, to make sure it works with multiple lines. Perfect. What else do we need here? I think we might also want to add the button at the top right corner, so we can go back from this tooltip window. We can go back with escort just by clicking on anything, but it's just nice to have that for visual clarity as well, providing another option. So let's select the root node, click on the plus sign or press Ctrl A, search for button. We can input back for the text. We can anchor it to the top right of the screen. We can definitely change under layout and transform the size of this to something like, I don't know, 14 maybe. And that looks much better. Go into move mode by pressing W, and we can just sort of position it a bit away from the corner. Go back to select mode by pressing Q. And one more thing we need to do is to rename this to back button, and also right click on it and access it as a scene unique name. So we have access to everything we want to see here. And that's probably it for the setup. Now we just need to code it so it works as we expect it to. So let's click on the Relic Tooltip, the root node, click on the attach script button. Relic Tooltip.gd is fine. We don't want to use a template for this, so that's perfect. Press create. And before we actually start coding it, we can connect to the GUI input signal to make sure that we don't do any typos. So go to node, select the root node, search for GUI input, double click this and connect it to this script. Okay, now let's see how we can code this. It will be pretty simple. Okay, so first of all, we'll provide a custom class name called Relic Tooltip. Then we'll have a bunch of already variable references, one for the icon, one for the tooltip, and one for the back button. Then in the ready callback, what we do is we connect the back button's pressed signal to the hide method, and we'll also call the hide method to make sure that the Relic Tooltip window is not visible by default when the game loads. Then in the input event callback, we'll check for the UI cancel event. So if we press the UI cancel, which is ask by default in my project, and this window is visible, then we call the hide method again to hide it. So this is just to make sure that you can close this window by pressing escape. We'll also have a show tooltip method, which receives a relic resource as a parameter. And what we do is pretty simple. We change the icon's texture to the icon we have for the relic and change the tooltip text by calling the relic's getTooltip method. The reason why we use getTooltip here and not the tooltip property is because relics might need to have magic numbers or custom tooltips given, and in this case they can provide their own functionality of receiving that tooltip. Then after we updated all the necessary information, we call show to make sure that this window is visible. And last but not least, for the GUI input event, if we clicked with the left mouse anywhere on the control node, the root node itself, then we again just hide the window. So we have basically three ways to close this window: pressing ESC, clicking on an empty space with left mouse button, or clicking on the back button itself. That's all we really need for this one. We just need to hook it up in the right places. So let's save this with Ctrl S. And before we hook it up, let's do a few things. First of all, there's one thing that bothers me and I forgot to do it. If you remember when we run the game and start a battle, the player has to expose by default, and I don't really want that. That's just a placeholder code from the previous episode I forgot to delete, which is a reoccurring theme now. So let's go back to player.gd and delete this placeholder code. I pressed Ctrl-Alt-O to quick search the scripts and go to player.gd. And you can see that we do indeed have this placeholder code here where we have 3 turns of exposed added to our statuses by default. We can just get rid of this for now and save this. And for the Relic tooltips to work, we want to use the event bus. So we also need to create a new event for the event bus. So let's press Ctrl-Alt-O and search for events.gd. So in events.gd, we don't have any events or any signals for when a relic tooltip is requested to be seen. So we can do something like relic related events as a new group at the bottom here and say that we have a signal called relic tooltip requested, which requires a relic resource as a parameter. Right, so that's all we need from the event bus. So we can save this with Control S. And now we can actually start hooking up this relic tooltip system. So let's go back to 2D view. And I still have my run scene open here, but if you don't, you can always press Ctrl-Shift-O and search for run.tscn. And here you can see that we have our deck view, right, where you can always view your current deck. And we want to do something similar here, so we can just select the top bar and click on the Instantiate Child Scene button or press Ctrl-Shift-A and search for relic tooltip.tscn, and you can see that we have now this one as well, but let's not forget to hide it by default because we don't need to see this when we start a new run. Right, to make sure that it's easy to hook up from code, we can right click on this and make sure it's accessible as a scene unique name with the %sign. Awesome, so now we can hook this up in code. So let's click on the run script. And the first thing we need to do is we need to grab an already variable reference to the tooltip, so we can maybe do it under the RelicHandler. I think it makes sense to do so. And we can say it's a relic tooltip window and access it with the %sign on ready. And the only other thing we need to do here is in the setup top bar method, right? That's when we initialize everything. And we do have one line of code which is related to relics here, and that's adding the starting relic to the available relics for the player. Here we also need to do connecting to the tooltip requested signal from the event bus, and we just say that, okay, we connect this to the relic tooltips show tooltip method, like so. And maybe just to like separate these a bit more, we can add some space between them so it's visible that they are separate entities inside the top bar. This is just a personal preference. Right, so that's all we need from the run.gd. And it's hooked up, but the problem is we never actually emit this signal, right? So if you remember, we do have placeholder code. So if I run the game now, and I actually want to click on this, it just displays this relic tooltip message, despite the fact that I do have the system ready for it. So where do we print this debug message? It was a long time ago, right? Well, we can always search for the string, right? So press Ctrl-Shift-F if you don't remember, and you can just type in relic tooltip was the message. And if you check the match case, then with the capital R, it will probably be a telling sign. And we do have one match. It's inside the RelicUI.gd script. Yeah, that makes sense, right? Because the visual representation of the relics is the RelicUI scene. So let's click on this, close the search results for now, and we can just replace this piece of code here with events.relic tooltip requested.emit, and we press the relic we have as a parameter. Cool. So now if we save this and run the game, click on the relic, voila, we do have our little description here. If I click anywhere, I can close this. So I can't click on anything else while I'm in that screen. I can also press escape, and I can also press this back button here, which is handy. Okay, so now we have our description. You can like style this, or you can change the look however you like. Maybe it's a bit pegged. Maybe the line spacing is not that good, but it's okay for now. We can at least know what our relics do. And I think that's it for this video. That's how we implement relics from Slay the Spire. Again, we'll come back to the event-based ones in the next episode when we implement shops and treasures. And I'll see you in that one. Bye-bye.